When you hear about climate change, what's the first thing that comes to mind? For many, it's a political battleground, heated arguments, opposing ideologies, and a seemingly endless debate. It feels deeply, fundamentally political. But what if I told you that at its core, the foundation of climate change isn't politics at all? It's something far more fundamental, far less negotiable. It's physics. We've become accustomed to framing climate change as a matter of belief, a partisan issue. Is it real? Is it human-caused? These questions dominate headlines and social media feeds. But this framing misses the point entirely. Imagine arguing about whether gravity exists or if water boils at 100 degrees Celsius at sea level. These aren't debates, they're observable, measurable facts governed by the laws of physics. Climate change, at its most basic level, falls into this same category. It's not about opinion, it's about energy, matter, and fundamental physical laws. So, let's strip away the politics and look at the physics. The Earth has a natural thermostat, and it's called the greenhouse effect. Think of our atmosphere as a giant, invisible blanket. Without it, our planet would be a frozen, uninhabitable wasteland averaging around -18 degrees Celsius. This blanket is made up of various gases, some of which are particularly good at trapping heat. These are our famous greenhouse gases, primarily carbon dioxide, methane, and nitrous oxide. Here's how it works. The sun emits shortwave radiation, which easily passes through our atmosphere and warms the Earth's surface. The Earth then radiates some of that energy back out into space as long-wave infrared radiation or heat. This is where the greenhouse gases come in. They absorb some of this outgoing heat, preventing it from escaping directly into space, and re-radiate it back towards the Earth. It's like a car parked in the sun. Sunlight comes in, warms the interior, but the heat struggles to escape, making the car much hotter than the outside air. The core of climate physics can be boiled down to a surprisingly simple equation: incoming solar radiation minus outgoing heat. For Earth's temperature to remain stable over long periods, these two values must be in balance. The amount of energy coming in from the sun must equal the amount of energy radiating back out into space. For millennia, this balance was relatively stable. Our planet's temperature fluctuated naturally, but within a range that allowed life to thrive. However, when we add more greenhouse gases to the atmosphere, primarily through burning fossil fuels, deforestation, and industrial processes, we thicken that invisible blanket. We're not changing the amount of energy coming in from the sun significantly. What we are doing is reducing the amount of heat that can efficiently escape out into space. If more energy stays trapped than leaves, the equation becomes unbalanced. And what happens when you continuously add energy to a system without allowing it to dissipate? The temperature rises. It's a direct, unavoidable consequence of the laws of thermodynamics. This is where the crucial distinction lies. Physics doesn't negotiate. It doesn't care about political ideologies, economic models, or personal opinions. It simply responds to the inputs. Add more heat-trapping gases and the planet warms. It's as predictable as dropping an apple and watching it fall. The scientific consensus on this isn't a matter of opinion polls. It's the overwhelming agreement among experts based on decades of rigorous observation, experimentation, and modelling. We see the evidence in rising global temperatures, melting ice sheets, changing ocean currents, and more frequent extreme weather events. These aren't isolated incidents. They are the physical responses of a system thrown out of balance. The argument isn't whether it's happening or whether humans are the primary cause. That part of the debate, from a scientific standpoint, is settled. So, if the science is clear, if physics dictates the outcome, then what is the real debate? The real debate isn't about the if, but about the how. How do we respond to this fundamental physical reality? This is where the political, economic, and social discussions rightly come into play. How do we transition our energy systems? How do we protect vulnerable communities? How do we innovate and adapt? These are complex questions with no easy answers, requiring collaboration, ingenuity, and a willingness to embrace change on a global scale. It's about finding systemic solutions, not just quick fixes or empty promises. It's about understanding the problem through the lens of physics and then applying human intelligence and cooperation to address its consequences. So, the next time you hear about climate change, remember, the foundation is physics. Greenhouse gases trap energy. The equation is simple. Incoming solar radiation minus outgoing heat. If more stays than leaves, temperature rises. Physics doesn't negotiate, it responds. The argument isn't whether it happens. The argument is how we respond. If you want to understand the systems, not just the slogans, and explore the solutions grounded in science, then make sure to subscribe to our channel. Let's build a future based on understanding, not just debate.